Good day. This is the KA intro, and it is quite a few sheets, so it's going to take a number of videos to work our way through. And we're going to be looking at weak acids and weak bases and getting a handle on how we deal with these things. So, K for equilibrium constant, the A refers to acid. We've already seen KW, and ultimately we're going to see KB. You have a K chart which lists the acids according to their strength. At the top 6 are shaded, and those are the strong acids, and that means their reactions go to completion. We have an arrow going to the right, and they completely ionize. On the other hand, most of the acids on the chart are going to be weak acids, in which case not all of the acid molecules will lose their protons. That means they don't completely ionize, and the bottom line is we end up with equilibrium, and we have to deal with them in an equilibrium kind of way, and that can include using ice charts. So today it says weak acids, and eventually we get to weak bases. Ka expressions are very simple. So I haven't included the states, and perhaps I should have, but this would be aqueous, water's liquid, and the other two things are aqueous. We only include the aqueous materials, so these are the products on top. Here's the reactant on the bottom, and we do not include water in the expression. Same for down here. Didn't underline too well. I guess we should try underline that a bit better. And so again, products over reactants don't include water. And one more, just to make sure. And again, products over reactants, and do not worry about the water. And it means once we have these expressions, we can do things with them. One, we could find a Ka if we have all this information. But it's quite common also to find the H3O+, because if we find that, then we can find the pH of a solution of a weak acid. So we'd know the starting concentration, we'd look up the Ka, and we'd solve for H3O+, and convert it to pH. So here we are. It talks about finding pH, calculating Ka. The textbook has lots of questions that love to do something called percent reaction. So those are things we're going to be showing you in the coming days. Process is you always write out your reaction. From that you can write out a Ka expression, and typically you're going to form an ice chart when it's a weak acid. Once you have your equilibrium values, then you can solve for whatever is unknown. So next page we're going to put this to the test. H2S is a weak acid, so we have to write out our equation. H2S plus H2O in equilibrium with H3O plus and HS minus. The minus I know is small to see, but it is there. So here's our ice chart. And we go 0.500, that was given. We're assuming we're starting with none of this. Now it's a bit of a lie because water itself will hydrolyze, but we're only going to have 1 times 10 to the minus 7 molarity of H3O plus in pure water. So usually it ends up being so small it's trivial. And so we go 0.500 minus x, x, and this is what we're going to use in our expression. Now, friendly reminder, this x value is likely so small, we can run with the 0.500, and we will. General rule here, and I believe another general rule is given another location, but the same basic effect. So if the initial concentration is more than 1,000 times the Ka value, typically we can ignore the value of x in calculating our concentration of the acid. So we have our Ka expression, x squared, 0.500, 9.1 times 10 to the minus 8. So we go boom, 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 and we get x squared equals this mess, 9.1 times 10 to the minus 8, and we get 4.55 times 10 to the minus 8. And therefore we take the square root of it, and now we have our value of x. The H3O plus and the HS minus in this question will be the same. Once we know it's 2.1 times 10 to the minus 4 molar, we take the minus log of it, and we get 3.67. This had 2 significant digits, and remember, this has 2 significant digits. The 3 really is indicating a power of 10. So that's a good place to stop the first video, and we'll carry on the booklet with the next video.